Alright guys, video 2 of memory is going to be a little bit longer, so let's jump right into it. When processing verbal information for storage, we usually encode its meaning. For example, we associate it with what we already know or imagine. And research indicates that this is called semantic encoding of meaning, and it yields better memory of verbal information than acoustic encoding, or of sound, or even of visual encoding, which is picture images. And we are particularly likely to remember words we can meaningfully relate to ourselves, and this is called the self-reference effect. This research also highlights the futility of trying to remember words that we do not understand and the benefits of rephrasing what we read and hear into meaningful terms. In a variety of experiments, researchers have documented the benefits of mental imagery. For example, we remember concrete words that lend themselves to picture images better than we remember abstract, low imagery words. We can remember concrete nouns better than abstract nouns because, for example, we can associate both an image and a meaning with fire, but only a meaning with process. Imagery is at the heart of many memory aids, including mnemonics. For example, in the peg word system, people remember new items by using a visual as well as an acoustic code, like 1 is done, 2 is shoe, 3 is free, whatever. When we organize information into meaningful units, we recall it more easily. And in chunking, we cluster information into familiar, manageable units, such as words into sentences. Chunking occurs so naturally that we often take it for granted. And when people develop expertise in an area, they often process information in hierarchies. And these hierarchies are composed of a few broad concepts divided and subdivided into lesser concepts and facts. In this way, experts can retrieve information efficiently. Hold on, I'm trying to get something to, I'm trying to find the picture I'm trying to find the explanation for this. Yeah. When we organize information into meaningful units such as letters, words, and phrases, we recall it more easily. So if you take this and you turn it into something, like you twist it back around and you turn it into something that makes sense, and then you turn it into a sentence, and then you turn it into an even more understandable sentence, you're always going to remember this. And these are the hierarchies we were talking about. Information first enters the memory system through the senses, and iconic memory is a momentary sensory memory of visual stimuli, a photographic or picture image memory lasting for a few tenths of a second. Echoic memory is a momentary sensory memory of an auditory stimuli. Even if attention is elsewhere, sounds and words can still be recalled within 3 or 4 seconds. And right here, the Sperling's memory experiment is referring to George Sperling. He asked people to do something similar when he showed them for only 1/20th of a second 3 rows of 3 letters each. So after 9 letters disappeared, people could recall only about half of them. And it wasn't because they had insufficient time to glimpse them. The researchers cleverly demonstrated that people actually could see and recall all the letters, but only momentarily. Our working or short-term memory span for information is just presented as very limited, and a second's long retention up to about 7 items, depending on the information and how it is presented. Short-term memory or short-term recall is slightly better for random digits than for random letters, and it's slightly better for what we hear than what we see. And without rehearsal, most of us retain in short-term memory only about 4 informational chunks. So the magic number 7 is good for our memory. Why do you think we have phone numbers that are 7 digits? And then plus or minus 2. We can usually remember chunks of 5 or chunks of 9. And then, you have all your magic 7. 7 wonders of the world, the 7 C's, 7 deadly sins, primary colors, musical scales, days of the week. We remember a lot. We tend to group things as a human race in groups of 7 because it's easy for us to remember. Although we know that our capacity for storing information permanently is essentially unlimited, we are not sure how and where we store it. And research has shown that many memories do not reside in a single place, and the so-called memory trace is difficult to find. And this is the World Memory Championship records. I think this is really cool. The search for the physical basis of memory is now focused on the synapses and their neurotransmitters and on the long-term potentiation, or the LTP, of brain circuits. In response to increased activity in the neural pathways, neural interconnections form or strengthen. And studies of the sea slug indicate that when learning occurs, the slug releases more of the neurotransmitter serotonin at certain synapses, and these synapses become more efficient at transmitting signals. And in experiments, rapidly stimulating certain memory circuit connections has increased their sensitivity for weeks to come. This LTP appears to be a neural basis for learning and remembering associations. Drugs that block LTP interfere with learning, and scientists are developing and testing drugs that enhance long-term memory. One approach is to develop drugs that enhance the production of the protein CREB, and another is to develop drugs that boost glutamate. Naturally stimulating hormones that we produce when excited or stressed make more glucose energy available to fuel brain activity. And this signals the brain that something important has just happened. The amygdala, the two emotion processing clusters in the brain's limbic system, arouse brain areas that process emotion. And these emotion-triggered hormonal changes help explain our flashbulb memories of surprising and significant events. Emotionless events mean weaker memories. Studies of brain damage patients who suffer from amnesia reveal two types of memory, and amnesia is simply the loss of memory. And the HM studies, this guy right here was HM, and doctors have called him the most important patient in the history of brain science. And he died in 2008 at the age of 82. And what happened to him, in 1953, he had a necessary surgical removal of a brain area involved in laying new conscious memories. And the brain tissue left his older memories intact, but converting new experiences to long-term storage was another matter. For example, over practice sessions, he became skilled at what is for anyone an initially difficult task, which is tracing the mirrored outline of a star. And having no memory for doing the task, he remarked to the researcher Brenda Milner after many practice trials, "This was easier than I thought it would be." Another researcher who said, "I've known HM since 1962 and he still doesn't know who I am," and that was in 2005. So there are two types of memory. Implicit memory is non-declarative memory, is retention without conscious recollection, and explicit memory or declarative memory is the memory of facts and experiences that one can consciously know and declare. Brain scans of people recalling words and autopsies of people who have had amnesia reveal that the hippocampus, which is, again, a limbic system structure, plays a vital role in the gradual processing of our explicit memories into long-term memory. And the hippocampus is lateralized. Damage to one or the other seems to produce different results. The left hippocampus damage, people have trouble remembering verbal information, and with right hippocampus damage, they have trouble recalling visual designs and locations. The hippocampus is not the permanent storehouse, but it's kind of like a loading dock that feeds new information to the cortex for permanent storage. Implicit memories are processed by the cerebellum, and research with rabbits in which different parts of the neural pathway were temporarily deadened during eye blink training pinpointed that implicit memory in the cerebellum at the back of the head. And our dual memory system helps explain infantile amnesia, which is when, again, infantile amnesia is like the fact that you don't remember anything until you're about 3 years old. That's your earliest memory. And this is a really great chart. I highly encourage you to, screenshot this. And that's it for today. Thanks, guys.